These are the 15 new discoveries made by AI. Number 1. AI predicts undiscovered planets. In 2025, astrophysicists at the University of Bern built an AI model inspired by language models, but trained on planetary system data. It learned the grammar of how planets orbit their stars and started predicting worlds we haven't even seen yet. By analyzing orbital gaps, the system pinpointed hidden exoplanets likely orbiting nearby stars. Its predictions are now guiding NASA's TESS and ESS's CHEOPS telescopes toward new discovery targets. It's one of the first times AI has expanded our understanding of the universe itself, showing that intelligent algorithms might soon help us find entirely new worlds beyond our own. Number 2. AI discovered antibiotics for superbugs. In 2025, scientists at MIT and McMaster University used generative AI to design new antibiotics that kill drug-resistant superbugs, like MRSA and Acinetobacter baumannii. These bacteria are on the World Health Organization's list as top global threats. The AI screened hundreds of millions of chemical compounds in just days and discovered molecules that outperformed some existing antibiotics in lab tests. What used to take years of trial and error now takes a fraction of the time. This breakthrough isn't just theoretical. It's already helping researchers develop life-saving treatments for infections modern medicine was running out of options to fight. Number 3. AlphaFold, protein structure prediction. Predicting how proteins fold was one of biology's biggest mysteries. Proteins shape every process in the human body, and misfolding can cause diseases like Alzheimer's. DeepMind's AlphaFold solved that puzzle. By 2022, it had mapped over 200 million protein structures, covering nearly every known protein on Earth. In 2024, AlphaFold 3 went further, predicting interactions between proteins, DNA, and small molecules. That leap helps scientists design new drugs and enzymes faster than ever. What once took years of lab work now takes hours, and it's completely reshaping how researchers approach biology and disease. Number 4. Genome, AI material revolution. In 2023, Google DeepMind revealed Genome, an AI model that predicted the stability of 380,000 previously unknown materials. To put that in context, that's roughly 800 years of discoveries at traditional lab speed. Several of those predictions have already been validated, showing potential for cleaner batteries, advanced solar panels, and superconductors. Instead of endless trial and error, scientists now have a roadmap of where to look next. Genome didn't just speed up material science. It changed the way we search for the building blocks of future technology, cutting decades off the discovery process. Number 5. Alpha geometry, AI in mathematical reasoning. DeepMind introduced alpha geometry, an AI system that tackled 25 years of geometry problems from the International Mathematical Olympiad. It solved 83% of them, matching gold medal level performance. But the real breakthrough wasn't just accuracy. It explained its reasoning step by step, the way a human would. That's a huge milestone for symbolic reasoning, a core part of human logic. Geometry drives fields like robotics, navigation, and computer graphics. So having AI reason through these problems could reshape engineering itself. Alpha geometry showed that artificial intelligence isn't just calculating anymore. It's beginning to understand. Number 6. Spectrogen virtual spectrometer. MIT researchers recently developed Spectrogen, an AI model that generates spectroscopy data for materials without needing a physical spectrometer. Normally, testing material quality requires expensive lab instruments, but Spectrogen can predict chemical signatures in seconds. It analyzes structure, composition, and molecular bonds virtually, giving scientists a faster way to test alloys, polymers, or even semiconductors. This approach cuts testing costs, accelerates discovery, and reduces waste in manufacturing. In 2025, the MIT team showed SpectroGen performing on par with traditional instruments across multiple datasets, making a big shift in how labs validate materials around the world. Number 7. Future House Autonomous Research Ecosystem. At MIT's Future House, AI isn't just helping scientists, it's running the research loop itself. The lab integrates AI agents that can design experiments, control robotic arms, analyze results, and suggest the next hypothesis in real time. This continuous cycle runs day and night, drastically cutting down the time between discovery and publication. Future House is already being used for material science and chemical engineering, where discovery often takes years. The project's goal is to eliminate scientific bottlenecks entirely, making breakthroughs a matter of weeks instead of decades. It's a glimpse into how science might operate in the near future. Number 8. AI Co-Scientist. In 2025, Google unveiled its AI Co-Scientist project, a system that uses large language models to assist researchers in every stage of discovery. It scans millions of scientific papers, forms hypotheses, and even proposes potential experiments or chemical targets. Early results show it identifying new molecular interactions that traditional screening methods missed. Unlike search engines, this model reasons through evidence, like a digital lab partner that never forgets a paper. Google's internal studies have shown productivity gains of up to 50% in early-stage biomedical research. It's not replacing scientists, but giving them superhuman research memory. Number 9. Robin, the multi-agent AI scientist. A team of researchers in 2025 created Robin, a multi-agent AI framework that can perform the entire scientific process autonomously. Robin can generate hypotheses, design experiments, run simulations, analyze data, and even draft research papers. During testing, Robin successfully identified a potential therapeutic compound for dry age-related macular degeneration, a leading cause of vision loss. The project, documented in an ARXIV paper, is considered one of the first examples of a fully autonomous AI scientist. It's part of a growing trend toward multi-agent systems where multiple AIs collaborate like a research team, sharing insights and refining results. Number 10. Self-driving labs for materials discovery. Researchers at the University of Liverpool demonstrated a fully autonomous robot scientist capable of designing and running chemical experiments 24 hours a day. Powered by AI, this system could hypothesize, test, and refine results without human supervision. It performed more than 700 experiments in just 8 days, a task that would have taken human researchers months. And similar projects are emerging at Argonne and Berkeley labs, where AI-guided robots accelerate discovery cycles for new catalysts and materials. These self-driving labs don't get tired or distracted, and that's speeding up innovation across physics, chemistry, and energy research. Number 11. Alter-magnet discovery. In 2024, physicists using AI models discovered 50 new altermagnetic materials, a newly identified form of magnetism distinct from ferromagnetism and antiferromagnetism. These materials combine properties of both, allowing electrical circuits to flow without resistance under specific conditions. The discovery, published on ARXIV and validated experimentally, could advance quantum sensors, data storage. Traditional methods would have required years of computation, but AI identified these candidates within weeks. For physicists, this was one of the first times artificial intelligence uncovered an entirely new class of magnetism rather than just optimizing known ones. Number 12. Boltz-2 drug binding predictor. MIT's Computer Science and Artificial Intelligence Laboratory unveiled Boltz-2, an AI model that predicts how tightly a drug molecule binds to its protein target. It runs nearly 1,000 times faster than physics-based simulations like molecular docking. That kind of speed could reshape drug discovery, allowing researchers to screen billions of compounds in days instead of years. Boltz-2 uses diffusion modeling to simulate molecular interactions with impressive precision. In tests, it performed on par with high-end molecular dynamics tools at a fraction of the cost, making it a practical tool for pharmaceutical research worldwide. Number 13. AI for diabetic eye disease detection. AI isn't just in labs, it's already helping save lives. Deep learning models approved for clinical use began screening patients for diabetic retinopathy, one of the leading causes of blindness. These systems analyze high-resolution retinal images and detect microaneurysms long before symptoms appear. Google's Verily and other medical institutions have deployed them in hospitals across India and Thailand. Studies in The Lancet Digital Health show they perform as accurately as trained ophthalmologists. With diabetes rates rising globally, AI-based early detection is becoming an essential tool for preventing vision loss in millions of people. Number 14. AI deciphers Herculaneum scrolls. In 2024, AI helped decode words hidden inside 2,000-year-old Herculaneum scrolls carbonized by Mount Vesuvius. The project, known as the Vesuvius Challenge, used 3D CT scans and machine learning to identify faint ink traces buried in the carbon layers. The first deciphered text revealed Greek philosophical writings unseen since ancient Rome. Funded by the University of Kentucky and tech investors, the model was trained on ink textures and geometry to reconstruct full letters. Historians call it one of the most remarkable intersections of AI and archaeology, unlocking ancient knowledge trapped for millennia. Number 15. AI discovers 303 hidden Nazca geoglyphs. Archaeologists in Peru used AI to scan aerial and drone images of the Nazca Plateau and uncovered 303 new geoglyphs. These are massive desert carvings depicting humans, animals, and abstract shapes. These findings, published by Yamagata University in 2024, nearly doubled the known collection of Nazca lines. Many of the newly discovered figures are too faint for the human eye to spot from above, but AI image recognition models could detect subtle patterns in terrain texture and color contrast. This fusion of archaeology and artificial intelligence is giving us a clearer picture of how ancient civilizations expressed art on a monumental scale. If you made it this far, let us know what you think in the comment section below. And if you haven't seen part 1 of this video, make sure you watch it now. Thanks for watching.